Assalamualaikum and hi, my name is Putri Nur Syahirah Binti Idris with Matric number AN180173 will present my final year project, a study of bamboo strip as steel replacement in concrete slab. I would like to start with abstract. Concrete is the most consumed material with 3 tons per use for every person in the world. Concrete has excellent characteristics in compressive strength but low in tensile strength. Meanwhile, steel is used as a reinforcement material due to its high tensile strength. The use of steel as a reinforcement material is limited due to its high cost, easy to rust, and contribute to air pollution with the release of carbon dioxide CO2 gas into the atmosphere during its manufacturing process. As an alternative to overcome this problem, bamboo semantan have been chosen as a substitute for reinforcement in concrete because it is a natural material, cheap and easily available. The size of bamboo strip cross-section used in this study are 20 mm, 10 mm and 8 mm. We'll compare with steel strength. The target slump are 30 mm to 60 mm with concrete grade used as C30. Testing method and procedure follow specific guideline from British standard. The result of the study show that the use of bamboo strip can provide strength similar to steel and potential in supporting the structure as well as minimizing the total construction cost. Introduction part. Continuous mean reinforcing bar, transverse reinforcement bar, and shear link are the most common type of reinforcement utilized in concrete. To avoid uncontrolled crack growth, it should be developed appropriately according to the respective design code. Nowadays, it is beneficial to manufacture steel with import material and properties. This is because steel is commonly used in structural material. Since bamboo strip will save cost, sustainable and strong compliant with standard, the objective of this study was to characterize the physical properties and mechanical properties of bamboo reinforcement material. Also, to determine the optimal size of bamboo strip to produce effective reinforcement and to investigate the flexural performance of bamboo reinforcement concrete. Total sample in this study are 29 samples, which are 3 beam, 5 slab, 18 cube and 3 cylinder. The significance of this study is to approach modification of steel with an environmentally friendly material. Also, reduce the issue of environmental pollution by replacing steel in concrete. Moreover, to utilize the application of bamboo reinforced concrete as a sustainable alternative to steel reinforced concrete structure. Next, literature review. According to a review of the literature on bamboo, there is a lot of research on BRC with normal strength concrete. It was discovered that there are few research work for replacement of steel with bamboo strip, and this will be covered in the current work, which will lead to a better knowledge of BRC properties, including strength in concrete. Over a century ago, concrete deformation such as shrinkage was tested with research interests ranging from fundamental mechanism of deflection to the effect of various influence factors, as well as structural issues related to the deflection. There is limited research directly addressing the effect in tropical climate. It's crucial to understand the amount of deflection for concrete under tropical conditions because the impact of surrounding indoor and outdoor relative humidity is quite considerable on shrinkage. Furthermore, because of the high energy absorption at the joint, bamboo can perform well in bucking when compared to steel. Based on previous literature review, it was discovered that despite significant development, only a few studies were interested in concrete testing in various types of bamboo. And there is limited studies specifically addressing the strength of bamboo semantan for BRC. It's crucial to understand the extent of deformation for concrete with bamboo strip. Next, for methodology, we can see it have a flowchart and DOE. For the flowchart, it starts with determination of experiment DOE, proceed with properties of bamboo strip, it will cover for objective 1. Next, casting 29 concrete sample, followed by curing sample for 7 days and 28 days. Next, performance of SRC8 and BRC. This will cover for objective 2. And next, start with experimental with slump test, tensile strength test, compressive strength test, water absorption test, ultrasonic pulse velocity test, and density test. Proceed with flexural performance of bamboo reinforced concrete will cover objective 3. Next, we can get the finding, analysis, data and conclusion, and we'll end the flowchart. For result and discussion, we can see a relationship between failure load and deflection of slab. Next, the graph also show the load failure, a relationship with flexural strength of slab. There are a number of variables to consider when determining the best BRC strength while working with the various bamboo strip size. It is critical for BRC decision-making process and for structural application. The performance parameter evaluate for the optimizing of concrete mixture might include strength, durability and other concrete parameter. The replacement of steel bar to bamboo strip serve many purposes, which are to evaluate strength of the specimen. The ideal bamboo strip cross-section indicated in the research consists of 8 mm, 10 mm and 20 mm. Based on the overall outcome and performance of PC, SRC and BRC, it can be concluded that BRC20 has the highest load failure among BRC8, BRC10 and plain concrete, while load failure of BRC20 is slightly below the load failure of SRC8. Contribution of the bamboo strip cross-section of 20 mm, 10 mm times 10 mm added more to the strength than the contribution of bamboo strip for 8 mm times 10 mm and 10 mm times 10 mm cross-section. Based on this observation, BRC20 produced the highest value of tensile strength in flexural strength and was considered as a benchmark for determining the ideal size for future work. That's all from me. Thank you so much for your time. That's all from me. Thank you so much for your time.